which I have a very vested interest in, which is supercharging your lakehouse implementation with Iceberg, right? So in this session, I will take you from the basics of what really lakehouse architecture is, what problem does it really solve, and how a complete enterprise lakehouse solution looks like, right? And the key Iceberg innovation that we have been working on here at Cloudera uh, very keenly, right? So later, my fellow speakers are covering very interesting topics like table maintenance, security, and adoption. So after this meetup, hopefully you'll have a holistic picture of what Iceberg adoption really means, right? With this, let me quickly give a quick introduction about myself. I'm Akshat. I'm a product manager for Open Data Lakehouse for Cloudera. I have a background of 8 years of experience in data engineering, where I've also contributed to a few Apache projects like Apache Hive and Apache These. In Apache Hive, I started contributing towards Hive Compaction, later transitioned into, and currently also contributing to transitioning Hive from JTK8 to JTK17, right? So if you're passionate about open source and new to the open source community, maybe I can talk to you after the talk and I can share 2 cents on how you can get started as well, right? So with this, let me dive into the agenda for today. We'll start with a deep dive of how data lakehouse architecture came into existence, right? What Cloudera's open data lakehouse looks like. Basically, what I mentioned about a complete lakehouse solution, right? What relation Cloudera has with Iceberg in general, the key benefits, and in later stages, I will talk about what the key innovation that Cloudera has been focusing on in terms of Iceberg, right? So with that, let me take you to this slide, right? So upcoming few slides actually have been talked a lot internally Cloudera by our SVP of product Venkat. And the reason why I wanted to reuse these slides is because how accurately it describes the current state of enterprise data and analytics state, right? So all your data today starts at OLTP platforms and your transactions databases, right? Be it your applications, be it your booking applications, be it your user management applications, etc. So all the data is actually generated there. Now, when you move ahead of it, you want to do analytics on this, right? That's when your data actually moved from OLTP to high performance data warehouses, or your data lakes, Hadoop, object stores, or any S3, for example, right? For analytics purpose. The problem with this is that this leads to a lot of data silos, if you see right here, right? And in turn, creates a lot of lack in visibility of data of what data is where. Basically, that's the question here, right? Which is creating a huge mess in data management, governance, and compliances, right? So in the end, what do you really want to do? Maybe you just want to build a report, right? Maybe you just want to perform a query like, okay, how many flights are delayed last month? For just that query, you have to do so much ETLs and create a lot of challenges later, right? So with this, what do we learn? We learn that data is everything. It is at every stage of your analytics, OLTP. So with this, basically data is everywhere at all at once, right? So talking about the challenges which I was mentioning, basically there are three major challenges that the current state, the data ecosystem has, right? Which is data copy, creating a lot of data silos, which in turns impacts the overall data duplication cost, right? Because you're performing ETL, but the data is already existing. Then it creates security gap on what environment, what users should have the access to it, creates governance issues, compliance headaches, right? And obviously additional storage costs that you're creating. The second biggest thing I think Iceberg is solving is vendor lock-in, right? So data is not accessible today because if you see enterprises today, not just use one vendor, they have multiple vendors. They have data in Cloudera, they have data in Snowflake, they have data in Databricks, etc. And to basically, let's say if a use case allows them to access data in Databricks, but their query engines are sitting in Cloudera, right? How do they access that data? So that's a problem that we have today, right? They have a lot of vendor lock-in and you have to perform ETL's job to actually transmit that data from one place to another. So with that, it creates, as I mentioned, you have to create a lot of complex and costly ETL pipelines. It in turn has high ingress cost. And again, limited capabilities, right? What you can really do is you don't have a complete view of the data, as I mentioned, because data is spread across different vendors, maybe sometimes. So it has an incomplete view of data. No native streaming and AI tool compatibility. Obviously, integration taxes and gap in lineage tracking, like how your data is progressing in its journey, right? So all these problems is is what basically Lakehouse architecture is solving, right? Now, talking about what Lakehouse architecture is really is, as the name suggests, data lakehouse is a union of two metaphors, data lake and data warehouse, right? The metaphors can be a great way to explain something and bridge the gap between something which is very familiar to you, which you see on a daily basis, and something which is especially new. And when it's complicated, it's become more easier to use metaphor. That's why I think these metaphors are there, right? So, however, with a word of caution, Lakehouse is an abbreviation of data lake and data warehouse, not a metaphor. So, because you can't actually relate a lake house, an actual lake house, to a data lake house. So with that caution, let me talk about a brief history on how these exist, right? So data warehouse is a term that has been there since 1980s, right? Which is primarily a system used to build report and analytics system on top of it. And let me be very specific, right? Reporting and analytics system on structured data. The emphasis here is on structured, because in real warehouses, things tends to be stored in a sense of order, right? In sense of grouping, so they can be efficiently stored and retrieved for use. Data is typically ingested, as I mentioned, from your OLTP platforms, as I mentioned in the previous slide, and then transferred to a high performance lake data warehousing system, which is what we call ETL, right? And in terms of data lake, this term has been coined in 2011 by James, who was the founding CTO of Pento. And from his perspective, James used this term data lake to draw parallel between how water is stored in data in its nature and raw state, and how data might be similarly stored in a data lake, right? So that's where the concept of data lake came in. And finally, data lake house, right? Which is, as I mentioned, abbreviation of both, which means that you can perform structured analytics directly on the data in the lake, providing you those capabilities, removing those copies and silos that exist there. So with this, I think we have an understanding of what a lakehouse architecture is, right? Moving towards what a complete enterprise grade lakehouse solution look like, right? So this, I think you might have seen a lot of presentation when we talk about Iceberg, right? But from an enterprise grade, there has to be a lot more. It has to talk about security and governance. It has to talk about lakehouse services. Just adopting Iceberg actually does not solve a lot of problems for these. So you need a proper solution on, you need the best in breed compute engines. You need, for different use cases, you have different engines. You have Impala for fastest queries, you have Spark, you have Flink, you have NiFi, right? So all those compute engines in one place. Then this is the area where I actually contribute the most. So as I mentioned, I'm the PM for the metadata management. So I manage the portfolio for REST catalog and meta. So so I have a very vested interest in this. And this solves the problem of the data access across different vendors, right? So this is actually solving the problem of vendor lock-in. So for example, if you have data sitting in Snowflakes and you have a REST catalog, so this REST catalog service, Cloudera's REST catalog service, enables you to securely create a data share and interoperability with third-party query engines from maybe Dremio, maybe Databricks, etc. Right? Then comes security and governance. So you need one place where you can manage all these security and governance policies, and then comes the Lakehouse service. So I'm a very keen advocator on this part, because replication optimization is as important as putting your data into Iceberg, right? So replication helps you in disaster recovery, right? What happens if your data gets lost? You need a replicator to have your data backed up and secured. Optimizer. So this is something I feel recently I've seen a lot of issues and interest in, because let's say you actually adopt Iceberg. You actually need to maintain the Iceberg tables as well, right? You need to perform compactions on it so that your query efficiently performs every time you use that. So optimizer is something which currently, if you do with Iceberg, there are some simple Spark procedures that you can perform to perform those compactions, expire snapshot, etc. But customers say that, like, this is my experience, right? Customer wants something more at an enterprise grade. They need something that they can just deploy and forget, right? They need something that runs autonomously, where without their interventions once they set it up. This is where actually Cloudera Lakehouse Optimizer comes in, right? It takes the load of optimizing your Iceberg tables and make sure that the queries run efficiently, so you can focus on what matters to you, right? And at the heart of it, what we are meeting it for, right, today, Iceberg table is the key which enabled us to build this architecture and create these use cases, right? And at the end, the storage layer, which is AWS, Azure, GCP, Ozone, and Hadoop, right? So this is how a complete Lakehouse enterprise solution looks like. These are some of the components that is required to build that. So not to go too deep into what really Iceberg is, because I think my fellow speakers are also actually going a little bit deeper into this. So just give you a brief, right, what Iceberg really is. So Iceberg is a high performance table format, which can scale up to petabytes of data for your huge analytics use cases, which Iceberg brings basically the reliability of a simple SQL on your big data, right? Basically entire data lake with by enabling query engines to directly work on those tables regardlessly. So with this, let me talk about how Cloudera and Iceberg are related, right? So Cloudera manages overall 25 exabytes of data on-prem and on-cloud for all our customers. Now, in general, right now, a lot of customers are using Hive, but we are standardizing Iceberg as a table format across the board. And in near future, we are planning to migrate a large size of that data into Iceberg. So moving forward about key benefits. So this is for general Iceberg as well as how you can utilize, right? So better performance. As I mentioned, Iceberg is very scalable to petabyte scale of analytics data. Second is it's open, right? There's no vendor lock-in that I mentioned again and again, because this is a very important use case for us. Multifunction analytics, you have multiple engines to query your data, advanced compatibility, and hybrid deployment, right? Then, so these are the few advantages that we have seen from our customers who are using Lakehouse or Iceberg in general, right? So Iceberg's ability to maintain data quality, consistency allows all the collaboration work to happen on the same data set, significantly improving your querying experience, query speed, reducing your compute size and storage cost, because you're not performing those heavy complex ETLs to transfer data from one place to another, right? Which in turns lead to 50% increase in developers' productivity, analyst productivity, cost savings in terms of storage and compute efficiencies, right? So let me just talk about a customer use case, right? So there's a sports automobile manufacturer, can't name it, but what was the problem, right, that they were having? So they were having slower response time as the data volume increases for them, as driverless capabilities, IoT features are now embedded in cars, right? What was the solution for them? So CTP Lakehouse improved their query performance and by implementing this architecture, which increased their time to value and time to market for these features that they wanted to implement, right? Team can access data faster because all the data now is in one place. And what Iceberg is giving them advantages because it's more performant at scale and additional capability like hidden partitioning, evolution, right? So what was the result for them? So they were able to get 10x better performance on their SQL analytics, tens of GBs of car protocol data now stored in just one place. And they can create predictive models, right, on top of that with just one place to access the data. So this is another use case, right, on how that diagram before that I shown and to this, right? How does this compare? Now you have a very simple architecture this way. You still have your OLTP where all the data is created. Then you might be using different query engines to basically perform one-time ETL, right? And storing all the data at one place, that is your Lakehouse Iceberg tables, and then access those tables via Impala, via Hive, via Spark, and perform all these use cases, right? Be it your MLAI models, be it your general data analytics query or data visualization, right? So going to next. So now I'll talk a little bit more about the Iceberg innovation that Cloudera has been investing heavily in, right? One is materialized view. Second is caching. So these two are the initiatives that helps you advance and accelerate your query time, right? Then we talk about replication, which enables you to have better disaster recovery, Iceberg on Ozone. And I think I was talking with Naveen also in the REST catalog, right? Which is a very keen area, which the entire Iceberg community is putting a lot of focus on right now. So let's get into this, right? So what really materialized views are? So materialized view is a common concept in DBMS where the system stores the query definition as a logical table, right? Which shifts the cost and basically the query is pre-computed and the resulting data is served when the materialized view is queried, right? So this basically transfer the cost of query execution to the pre-computation step itself, which makes your overall commonly occurring queries much faster that way. So we have been heavily investing in the Iceberg materialized view, and you can see our contribution in upstreams as well on this particular part, right? Upstream community. So with this, let me show you the result, right? What we were able to achieve. So we tested this on a TPCDS data, and you can see we achieved basically 40% average reduction is overall total elapsed time that way. Another top, did we have a question? Okay. So another topic for query acceleration, right, which is metadata caching. So as you know, during query planning, during query planning, manifest files, which contains the pointer to the actual data, if you see on the diagram on the left, right? So file operations such as opening the file, closing the file, relatively expensive. And Cloudera implemented manifest caching, also as clean caching, basically to reduce the read small Iceberg manifest files from remote storage. Right. From our benchmarks, basically, which I'll show in the next slide, demonstrate that we are able to achieve 12% faster query planning, which contributed to your overall faster query execution, right? And to enable this, it's a very simple configuration. As I said, that you just enable Iceberg IO manifest cache enable true. That's in overall caching gets improved. So this is the result. As I mentioned, we saw overall 12 times faster query planning and query execution that way. Now we talk about query replication. So this we are segueing into how we can actually set up disaster recovery backup strategy, right? So what's the use case basically? The simple use case is to have your data source, which is your Iceberg table. You need to put in destination, right? That's it. You have a disaster recovery that way. You create a copy of it, which enables you to have a massive support as well, which enables you to incrementally replicate your data. How it is actually implemented in a nutshell, right? So the basics are same, right? We perform ETL. Now, what would be the EL, sorry, not ETL in this case? What will be the EAT step in this, right? So here the export step, synchronizing the extract from the Iceberg table, it extracts the data, the metadata, which represents the table. Transfer case is basically synonymous with the loop, right? Where it is responsible for transferring data and metadata from source to destination, the transform, right? The same step which updates the transport metadata fields and Iceberg table that you have source right, to the destination. So with this talked about application, not but more, which is on Ozone. But Ozone is basically designed to scale to billions of objects, eliminating the small file problems. And Ozone is also designed to widely mount to use cases of extremely dense storage to support archival and infrequently accessed data, right? So what do you really get from adopting Iceberg on Ozone is better performance, 4x better storage density, 10x scalability in terms of, so it can actually, so if I have the data correct, we support up to 400 to 600 TBs per node. And this is not about cluster. You can keep on increasing node, right? And with basically erasure coding, you can reduce your overall storage to 3x to 1.7x. This is what we were able to do in our comparison and testing, right? So what are the benefits or differences between if your data is on Ozone versus HDFS, right? In Ozone, you have thousands of node, which can scale up to 600 TB per node, while in HDFS, you can have the same number of nodes, but it can scale up to only 100 TBs, right? So this is the data density that you can achieve in HDFS and Ozone. Then talking about scalability, in Ozone, you have 10 billion objects. In HDFS, it's still 400 million objects, right? In terms of recovery, it has faster recovery than HDFS, and availability is painless deployment. And while, right in the Hadoop industry, it's still a big mess to scale it and make it available. So, and the protocol support is same. Hadoop and S3 API is supported in Ozone. All the objects are S3 API compatible, and in HDFS it's basically Hadoop API. Now, this is, I think, sorry? Menu. So we don't have the stats yet, but I think the team is working on getting those stats fits, and maybe we can talk in some separate session that happens after this, right? So REST catalog. So this is one area which I think Iceberg industry, if you follow the upstream community, is focusing a lot on. And we recently announced our TP of Cloudera's Iceberg REST catalog with, as I mentioned multiple times in before, right? It avoids vendor lock-in, which means that you can access data from one place to another. This is basically creating an open table format. By creating an open table format, we are achieving access from anywhere as well, right? With the REST API service. So REST interface actually is performing those Iceberg metadata operations, allowing access of Iceberg data from in the entire Iceberg state from just a REST API, right? What are the features for this, right? So as I mentioned, one of the key features is enabling third-party engine interoperability from any vendor that way. Supports secure table sharing using remote signing, and adding new features like multi-table commits and caching. So what are the benefits, right? As I mentioned multiple times, but I need to emphasize this on more, that it creates open standards and creates an engine agnostic approach. You can use any engine that has a REST client and can call REST services to get access to your Iceberg data via REST catalog. Eliminates data silos. Even if you have data in different vendors, for example, Snowflakes, Databricks, Cloudera, it eliminates basically the data silo, right? By if any engine in Cloudera has REST client, it can actually connect to REST catalog and access the data there, simplifying third-party engine access and enforcing security and governance at one level, right? Now you don't have to worry about enabling security and governance at all the stages where you have your vendors. You just need to enable your security and governance and manage everything at one place, which is the REST catalog, which reduce your overtime to value and time to market, right? Basically, if you're building product using these solutions. So with this, I think I'll end my presentation in time, luckily, and have 5 minutes for questions. So I think if you have any questions, yeah.
Hey man, hello.
Hi.
Good presentation.
Hi.
So just one question on that Ozone thing. So is that kind of, is it available on AWS? I mean, how do you get access to this? Is it a Cloudera proprietary object storage format that I have
Ozone is Apache Ozone, right? So it is available. It's open source.
Okay,
basically.
so anybody can use it. Okay,
Yeah.
okay, understood. Perfect. Thank
you. Why Iceberg is prominent?
Yes, why Iceberg was used. Is there any particular reason? Because I saw some real-time use case, and I believe Hoodie is better.
Yes, Hoodie in particular, those use cases still better. But if you talk about adoption overall, Iceberg has a much better adoption. So if you see even data lakes, Databricks, right? So they had data lake, Delta Lake that way, but they are now Iceberg prominent as well. So the adoption is much easier for Iceberg. There are still use cases where Hoodie actually might serve your streaming use cases better. But in general, Iceberg suits your overall use cases much easily than Hoodie. But basically, they're solving the same problem in streaming and batch use cases as well. But it's about more adoption as well. Like for use case, you can actually use Hoodie as well. Any other question before we move to, yeah.
Yeah, my question was what kind of optimization was done in with Hadoop on top of Iceberg? You spoke about optimization.
So yeah, let me talk about that, right? So without the slide also, let's proceed to that, right? So optimization on an Iceberg table basically means like on optimization can happen on multiple stages, right? It can be at a query level, which was solved by metadata caching and your overall the way you implement things in different ways. But what optimizer was talking about is table maintenance, right? So for example, let's say if you have a streaming use case, but that's say, right? And you have a micro batch size, which is very small that way. It creates a lot of small files in very small period of time, in a very short period of time, which creates a problem of small files. Now, when you query that data, you have a lot of small file problems. That means that your query time and even your query planning itself will have to traverse through all that data files and metadata files, right? So you need to maintain that. You need to compact that into bigger files to be able to access that data faster. So that's the optimization that we were talking about. It was mainly focused on table maintenance, expiring your orphan files, expiring your snapshots, managing your metadata files better, creating appropriate size file that gives you the query performance that you need. So that's the optimization that we were talking about in that slide. So mainly focus on the table maintenance side.
Yeah, I got this part. And just one question I had. We speak about the hidden partitioning that is done in Iceberg, right?
Mhm.
I just wanted to know on what parameters does it consider to do this partitioning? Like that's automatic.
That's a
right?
very valid question. So I think, but for that, we'll have to go much deeper into this topic for hidden partitioning, which I think maybe we can take offline as well. Sure. It's basically on how you build the use case, right? So once you have the replication done, it's up to you on what basically where do you want to point to your use case, which use cases. Yeah, exactly. Yeah. Which copy, but again, right, like the whole problem that we're trying to solve is removing data copies. So if you make active, it basically creates an active copy of the same data and you're using it. It increases the storage cost as well and creates ultimately the same problem.
What type of metadata we are talking about in metadata cache?
We're talking about the table metadata, right? So how your table is organized. So we actually didn't go deeper into the table form, what table formats are, right? So Iceberg in general is a table format. So how your data is actually stored. I think in next session, Naveen has some structuring of the table, right? How the table is actually stored. You have your directory and where the files are managed, how this relationship is managed as the metadata. On, for example, let's say if you're running a query, right? The query needs to know where the actual data is. And how does that happen, right? The metadata is what have the locations, have the links on how to reach that data as well. So that's the metadata that we're talking
Okay, so materialized views are below metadata cache. That means like first we have to access metadata cache to get the
So
to get the storage.
these are separate topics altogether. In that
Okay.
way, I think we can get deeper into that in
Sure.
offline.
Okay.
Thank you. Oh, my voice was breaking. Okay, didn't know that. Getting better just now. Same. Sorry. I can't see that. I only see. Sure.
Question is from Chayan. Could you please elaborate on how Ozone achieves these improvements and what makes it more efficient than SDFS for modern data storage needs and chunks?
A very valid question. But again, so this is a much deeper topic on how Ozone is implemented to achieve these things. So basically, just think of it this way, right? Today, we have different storage, we have different query engines also. But what really differs is not the use case, because ultimately you're querying the data, but how you're doing it and at an implementation level also, right? For example, if you do Impala versus Hive, if you do Hive versus Impala or Trino, so all of those are implementation level details that are creating these differences. And we'll have to go into deeper into how Ozone is implemented that way to get to that answer. But I think we can organize I think we had a Ozone meetup as well, right? Something we did. I think we can share those details and we can talk about that. So with that, I think I'm up with my time. So thank you so much. I hope this was helpful and I'll pass it.
Thank you so much, Akshat, for sharing the insights. I request Naveen to start with the next talk. Naveen works with Dreamio and rest he will start with his introduction. Thank you.
Okay, hey everyone. Thanks Akshat for last session. This is Naveen. I'm engineer at Dremio. I basically contribute on Iceberg side. I'm not committer and all. I just started contributing, and also I work at a Dremio at part of query engine team. This is just brief about me. I'm going to talk about table maintenance. As Akshat mentioned, this is like one of the very hot topic as well. It's becoming hot because Iceberg is becoming hot and the adoption is becoming more and more, and people are coming with new set of problems, and no one wants to compromise on the performance, right? So we have to do something where the performance should always be in line with the expectation. I'm gonna talk about it. I have especially mentioned, I'm only like with examples and all, I'm only going to talk with Spark because Spark is, I can't say more advanced, but any functionality when it gets developed with Iceberg, first contribution or first adoption happens with Spark because the same time we plan to integrate with Spark and just like to run examples and do the demo and all. Right. So any functionality is being developed on the Iceberg, Spark will be the best engine to go and validate. Yeah, let's not talk about how Spark works in terms of performance and cost and all. You know, EMR is one of the best solution which is provided with Amazon, but it's very costly. So yeah, I'm going to skip those parts. So in today's agenda, I'm going to talk about like, yeah, so Akshat has covered some basics about Iceberg. I'm also gonna like talk slightly about what is Iceberg, and since my main topic is table maintenance, so my focus area will be why do we need a table maintenance exactly? What's the problem there? And then when do we need and how to run the table maintenance? Why, how? Because I have attended few of the meetups and yeah, I'm heavily like working with customer issues and all, and everyone comes up with this set of problem. When should we run and how we should run? Because this is one of the very expensive operation. It's more expensive than any other read and write, right? Read is always like in a second and all, right? You can't compromise on read performance for sure. Write sometimes becomes expensive when you are like dealing with large set of data and running queries like CTAS or insert into select star kind of thing, right? But the maintenance is more and more expensive because it deals with the entire ecosystem of, say, Iceberg table format, right? At that moment. So yeah, so what is Iceberg? Yeah, it's very known kind of definition. It's open table format. Why it is famous? Because of how intelligently it is managing the specs. That's why it's becoming more and more hot and more and like famous. People always compare Iceberg with other formats like Delta Lake or Hoodie or I forgot some new format is coming. But Iceberg adoption is happening only because the way they are managing their specs. And every day some new innovations are happening. The community is very strong and like very highly active, and they always try to like come up with some unknown problems and fix it ASAP. Right. This is again known thing. It follows semantics of all the relational DB. Okay. So I need some details like how many of you are already using Iceberg, because accordingly I can go into the details, right? So, okay, good. Okay, so yeah, so let's talk about what is Iceberg a bit. So Iceberg works well with metadata, and end of the day, everything, all your data gets stored in the data file, right? This is like common for every table format. So how actually it generates those metadata? Any write operation, or in fact, any operation you do, whether it's a DDL and DML, everything it creates is like kind of immutable, right? So in Iceberg ecosystem, everything is immutable. So yeah, let's focus on first DML operation, right? So any DML operation you are doing, it create a new snapshot. That snapshot gets linked with something called manifest list file. I have like kept it at abbreviation because of the space issue, right? So yeah, don't get confused with S0 and ML1. So snapshot, always people talk in kind of zero-based index. So that's why I have given it as a 0. And then it has yeah, one-to-one mapping with manifest list. Again, as Akshat was showing that diagram, one manifest list can have multiple manifest files, right? So one manifest list can get linked with multiple manifest file, and each manifest file can have multiple data files. So end of the day, if you do one write operation, it will do this kind of thing, right? For every snapshot, these many files might get generated. It's not necessary it will generate every time more number of data files. It depends upon what kind of operation you are running. So just in one scenario, this is what one write operation, one DML operation will look like. Let's ignore kind of delete scenarios, right? So yeah, let me quickly show you what is the meaning of this, right? Sure. Okay. So this is, I'm not sure how much you're able to see here, right? Yeah. So I just copied a one metadata JSON file, which is called the first metadata file, right? So with every write operation, it creates like this file with this much information, right? You can see here, other than like, I'm not sure how much I can zoom. So previously, all these other information like table schema, partition details, all the things are stored. And then there is something called snapshots, right? So snapshots is an array here, which is storing multiple snapshot. And each snapshot, you can see like all the details are there, right? So these details are not like just for a, like for some purpose, I mean, just for like random uses, they have kept it for with every detail is being used by some mean. When we do read or write, all the fields are being used here, right? If you can't just randomly store anything because your snapshot, your JSON file will start becoming big and it will start impacting or your read performance. So I was talking the first slide about intelligent specs, right? So here people spent a lot of time how to, I mean, this is not exactly part of compaction, but they keep discussing how can we shrink it and maybe make it more less in the size, because this is the first file when you do either read and write gets loaded in your engine, right? Any engine you are using. And as Akshat mentioned, nowadays, many engines are coming with like keeping all this information in cache, right? So if you keep more information in your JSON file, your cache will start becoming big. And again, eventually, a lot of impacts will start happening. Yeah, this is problem with my slides. Okay, so you do again, next insert operation, it does the same thing, create a new manifest list file. But now what it does, it keeps the reference for the previous manifest files as well, right? This is how the metadata ecosystem works, right? It does not lose your previous information. That's why write and everything is very fast, because so if you can think how exactly your write is happening. Okay, let me add something like this, right? So your new data files got created. It got mapped to your manifest file, and your manifest list just put a reference to the previous manifest files, right? So now if you try to read or any operation you'll try to do on the new snapshot, this is one, right? You are not losing any information. What you are losing is a reference to the previous metadata files, and that also with the JSON, which is like a snapshot file, you can say, and the manifest list file, right? Again, you do another write operation, another set of data files got created, and again, it creates reference to the previous manifest files. So this is how your eventually your Iceberg ecosystem will look like with multiple DML operations. I'm saying DML because it can happen like delete, update, merge, insert, any operation, right? So end of the day, your Iceberg ecosystem is looking like this, right? Are you guys with me so far? Okay, please, yeah. ML is called manifest list. Yeah, why list? Because it has information of all the manifest files. Okay, MF is manifest and is snapshot, but it is basically kept in a JSON file, metadata JSON file. So Iceberg and Delta Lake has slightly difference how they maintain a metadata, right? Delta Lake, I don't have enough knowledge about Hoodie, but Delta Lake has a different way of managing the metadata. Iceberg has slightly different of managing the metadata. Right. So after all your write operation, this is how your Iceberg will look like, right? So if you'll see, lot of files, lot of information are there now. If you're not going to maintain it, as in the previous talk, it got mentioned, right? For any query, imagine how many IO will happen here, right? So say you are at snapshot 2 and you are planning to read the data now, right? So Yeah, so any engine, so it's an engine intelligence again, right? So Iceberg gives you a capability of pruning at a different level. What does it mean is, you are going to run a query, read query say, first pruning will happen at a snapshot level. Even though you have 1,000 snapshots, it is only going to read the current snapshot, right? Again, Iceberg has capability of doing time travel. So if you will mention the particular snapshot, it will only refer to those snapshot. It is not going to kind of face the previous snapshot or other snapshot information, right? So first pruning happen at the snapshot level. Second pruning happen again at the manifest list level. But again, since every snapshot is linked with only one manifest list, so by default, you will land here on the manifest list 3. Now you have multiple manifest files here. Suppose you are running a select query with date range and all, and if it is going to read all those manifest lists, right? Tomorrow, I mean, in a big companies or in many use cases, you'll have millions of manifest files, right? Suppose streaming use cases where you are every hour or every minute doing some write operation, eventually in a month or in a day, it will end up creating huge number of manifest files, right? So your read cannot go and try to load every manifest file and fetch all the required information, right? So the third pruning happens. So when it loads the manifest list file, it try to prune which manifest file I should read now, right? So it does not load all the MF from 1 to 4. All the engine intelligently understands, okay, for this particular query, I have to only load manifest file 3 and manifest file 4, right? Now, fourth pruning happen at the data file level. Again, with the query, it understands, okay, my data is only present in, let's say, range DF9 to 11. So it only loads those information. This is how your query planning works, right? That's why it is very fast. Even the petabyte of data, it like gives result in a minute, not more than that, right? It depends upon what kind of query you are running. But again, it is a problem. You cannot expect your engines to go and read again like this number of files. So you try to find a way, how can I reduce my IO, right? Because IO is the one of the expensive operation during read part, right? For write, again, it's a different game altogether. But for read, if you're doing more IOs, I'll talk again in the next slides, your read is going to be very, very slow, right? So if your ecosystem is looking like this, you really need some kind of maintenance so that it's not only about performance, eventually you'll end up keeping a lot of data in your storage and unnecessarily will be paying a lot of cost for that, right? So here is a question. Why do you need to maintain the previous files? Because you know now you are not going to read it unless you have a time travel use cases. So time travel means even though you did some write operation, now you are at snapshot 2, let's say something bad happened, or say your data got corrupted in the new snapshot. This is what happens regularly. So you are planning to maybe either roll back to the previous snapshot, or there is say you want to compare like how much sale happened yesterday versus today, right? So you can always fetch the data from the yesterday snapshot and for today's snapshot, and you can find the difference and all, right? So no, yeah, I mean, it will not go to particular snapshot. If you're giving time range in your query, it will always go to the latest snapshot or current snapshot, but the pruning will happen because you have mentioned this filter query, right? It will happen at the other metadata level. So say at this level, it will just try to pass those query things and say, okay, give me the manifest file for this time range, right? Depends how you are keeping your data, right? Yes. So if you say you have not partitioned your table, or the time range column, what you are mentioning is not a part of a partition, then pruning won't happen. If it is a partition column, then only pruning will happen at that table, right? So those are a different intelligence, like how you are creating partition, right? This is very much self understanding thing, right? If you really want an intelligent pruning, so your data should be really like organized in that way. So your partition is say like kind of weekly basis, and you are planning to every day run query on the monthly basis or say yearly basis, right? So you won't get an intelligent performance or good. Yeah, so schema evolution, all those things is not like a DML, right? It's like a definition change. It does not create a new snapshot. It will just create a new metadata registration and add those new schema. And because why it is intelligent and why it is way better than all the relational DBs, it does not try to change everything in your data file channel, right? So data files, the column name does not exist. It's like column ID. So if you're adding a new column or changing or renaming something, it just happens at the very first level. That is called metadata. Right, right, right. Yeah, next time you're doing write operation, the new column will get populated. The new data data file will generated with those new columns. But previous data files, right? This is where your data are being stored. Won't have any information of the previous column. So, yeah, yeah. Okay, so this is what I'm planning to cover, right? As part of table maintenance. So these are the scenarios so far we have come up with in the Iceberg side, right? So we can do compaction. Compaction means at the metadata level and as well as a data level, right? Both are expensive operation. And then there is something called garbage collection. What is garbage collection is deleting all the files or all the information what you don't need now, right? So it's not only the files which are not required. If you are heavily doing write operation, eventually you'll end up creating lot of orphan files because your write will, let's say your write is failing continuously, right? Lot of orphan files will be generated. So all those parts will come under garbage collection. Garbage collection is more about definitely for performance, read performance, but more about cost saving on storage side. So compaction, we have three parts here. So far, Iceberg has like three flavors of it. One is called rewrite manifest. The second is data files and then positional delete files. Garbage collection, again, we have expired snapshots and remove orphan files. Okay, so again, I think so far we discussed a lot. So this is very much self kind of explanatory thing. Why we need rewrite manifest is like the first metadata, which is like more in the numbers, and we spent a lot of time reading it, right? So query planning spend a lot of time on metadata reading. That's why all this caching and all those flavors are coming, right? Because every engine is trying to come up with a new set of implementation and trying to be different from other engine. So only places they can do more optimization is the metadata level. I mean, definitely they can do other lower level as well, but this is like one place if you are coming with more intelligent solution, right? Because see, as like Cloudera was talking about, right? They're going to cache it. So someone asked like, what information you are going to cache it? Again, you can't cache everything, and frequent writes are happening. Your cache are going to be updated every moment of time, right? So again, it is going to come up with a new set of costs. So engines are spending a lot of time on understanding what exactly we have to keep in the cache, right? So all this schema evolution change or spec evolution or manifest level, what all the information we have to store it. Like you guys are familiar with the S3 table, right? So they are playing a lot with cache now. That's why they are claiming they're like going to be more faster than any other engine. Yeah, I'll talk. I'll come to that slide and maybe I'll talk on that. So yeah, this is like advantage we'll get for rewrite manifest. Faster metadata scan, speed up performance. As I mentioned, I'm only going to talk on the Spark side. So Spark has something called procedure, which is looks like this. Again, it has a lot of different flavor. I have not covered everything. Iceberg has very nice document. You can always go there and find. Yeah. Yeah. Yeah, so you can't do this, right? So your streaming is also happening and you are running table maintenance also. A lot of conflict will start happening at commit level. So we'll see a lot of failure. So suppose you are doing write and you are also, and your write is something like merge operation, right? And you are also running compaction. What does it mean is you are saying the previous data files are not needed. You are, and the new operation is saying I have done some deletion on those data files. So the conflict will arise. Compaction will say I am compacting data file 1 to 3 in the new data file, and your merge operation is saying I am deleting, or the delete operation is saying I'm deleting the data file 1. So during commit level, whoever will go last, there will be conflict, and your commit will start failing. So it does retry, and after some retry, it may get success or it may fail. So generally, again, like it's a use case basis. People try to run the maintenance during peak time, like in the night shift. I mean, during night or maybe the morning time kind of thing. Because as I mentioned, compaction is a expensive operation. If you have thousands of data files, it may take hours. Depends upon what kind of data structure you have. It may take hours also. So you really have to be careful when to run the maintenance. For streaming, definitely you have to run more and more frequently. Yeah. Definitely there is one problem of a small file, but imagine the number of metadata files, right? Yeah. So if you have a real-time use case, means some data came and you want to read it now, right? You can take that risk to run maintenance also, like maybe hour basis, but again, both will. If streaming is also happening and we're running maintenance, some conflict will happen, and one of the operation may fail. Yeah, so with every write, you are creating a new snapshot, right? And now you are going to like find when I should run the maintenance. So you have to find that time window, right, where the load is less, or your write operation is less, right? Otherwise, you'll end up doing a lot of conflict. That is there is, I don't know. I mean, there is some standard definition. Okay, now you should run the maintenance, right? You have to come up with a time window where write is less, right? So that people can, again, it's not only about write. When you run the compaction, it takes lot of CPU. So maybe your other operation will start failing. So what people do is they deploy different cluster, one cluster for maintenance and one cluster for all the read and write purpose, right? So it has lot of, it's a very expensive operation. So you really have to be careful. I have covered in one slide how exactly and when we should run. I'm running out of time as well, so I'll try to go a little fast, right? So you have this manifest file, and then you did the rewrite manifest. RMS stands for rewrite manifest. So just see, all the previous manifests are gone now. So now you have only one manifest. So when you do the read, it will only read the one manifest file. All the previous manifests are gone. If you look on my boxes, right, it is eventually increasing. So see, the first snapshot is less in the size. Because of the more snapshot, the more bigger your metadata file will become. So if you see in the manifest list, 4 is very small in size because it will have a only less number of manifest file, right? So it will look very small. So similar way, more data files, all these problems will be there, slow queries, right? And a lot of waste storage will be there. So if you're doing data files, this is like most useful thing. People don't run rewrite manifest frequently, but they do run rewrite data files, as you said, because of the small file problem. And why is that? Because manifest compaction happen at the iceberg level also. So they have something called rotational basis. So when they find like your manifest file is becoming this big or maybe in this number, they will automatically rotate and create a compacted manifest file. So all those configurations are there in the iceberg, right? So again, when you rewrite the data files, you have a lot of options, like what should be the target file size, min max file size, right? And there is something called incremental optimization. This is very important, and this is only available in Spark as of now, if I'm not wrong. Maybe other engines have worked on it. I am not 100% sure. This is very important. Why? Because if you are going to compact millions of file, and suddenly after an hour it will fail. All the time and all it will is gone. You'll have to rerun, right? So Spark has come up with something called incremental optimization, which will keep doing in a batches. So it's very, very intelligent feature, and it has requires a deep understanding of it actually. But yeah, it's there with Spark, right? Okay, so these are the flavors are there, which will do the less memory pressure. As I mentioned, it takes a lot of memory, right? So you can define some number of file groups and file group size and all the things. So end of the day, when you run rewrite data files, it will look like this. Everything got compacted. Now we have only one data file, right? And again, say other data files are already of optimal size. So it will keep reference to the previous manifest file, right? Right. After that, this is like one of the number I ran an example, like some examples within Dremio. So this is the difference we found with the select. But this is with the Dremio engine. Before optimization, it was taking that much second. And after optimization, yeah, it was taking this much second. If you see the first one, after optimization, also it is taking more time. Why? Because in the first one, the files were of the bigger size. And after optimization, we were trying to break into the smaller file size. So again, these are like information you should be careful when you are planning to run, and what are the advantages you will get after running it, right? So I've just kept as a bullet points. I don't have enough time to explain. I'll rewrite positional delete file. Again, if you're doing frequent deletion, it ends up creating a lot of positional delete. So that also we can maybe compact it and create a one delete file, right? Expire snapshots, what it does is it expires all the previous snapshots. So again, you have to understand which snapshots are not required for time travel. So it does expire those snapshots and remove all the metadata files related to those snapshot, right? So in this diagram, yeah, this is what it does. It expires and it deletes. So if you see, it is only deleting the manifest list 1 and 2. It is not deleting the manifest other files. Why? Because you have not run the compaction. If you run compaction, your MF1, 2, 3 will become kind of like unused for the current snapshot. So it will delete those files as well. Since current snapshot is still referring to those manifest files, that's why it is not expiring or basically deleting those files. So not only manifest files, it will delete the data files as well, right? And remove orphan files is why? Because any write operation, it ends up creating some orphan files. So if people keep running frequently, it keeps freeing up some spaces for you, right? So this is what. So let's say some failed commit happen, and this is what the metadata files you end up generated, which is not linked to any of the snapshot. So you want to clean those things also, right? So just run remove orphan. Remember, it is only deleting the orphan files, not anything related to live files, right? So yeah, this is, I think someone asked like how and when we should run. So say your table is looking something like this, right? Now, what is the order of running the maintenance? So this is, I don't know, like this is some standard practice, but this is what my understanding is. First run rewrite manifest. You'll end up having this kind of a data structure. Then you'll run positional delete. And then you'll have, again, like it will only compact the positional delete file. Then when you are running data files, so end of the day, after all these three operations, your current snapshot and current table is looking like this, right? So now if you run expire snapshot, what it does, it creates a new snapshot. It will refer to the previous manifest list file and it deletes everything. So all the previous files, what you stored in your storage system has been deleted. Right? So this is just my understanding. This is how you should run. But again, people might have a different opinion about it, right? So if you're doing something like this, you'll end up freeing up a lot of spaces. Now your table will look something like this. Your read will become very faster. Plus, and Sorry, you're not. Yeah, so manifest file, the standard size is 8 MB, right? So when you run rewrite manifest, it will end up creating manifest file of 8 MB in the size. And let's say you have more number of data files, right? So it will create more number of manifest file. Manifest file you cannot create in GB or more than. Yes, yes. Yeah, so then you don't run expired snapshot. You can always go to the previous snapshot. Yeah. That is the beauty, right? If you have this kind of doubts, like something might go wrong, right? You always take this. So your expired snapshot and remove orphan file. Remove orphan file you can run anytime, but expired snapshot you should be really careful when do you want to run, because it is deleting those files. So like hard deletion, not a soft deletion. Okay. So if you don't have a time travel use case, as you said, some maintenance job you are running and you are not sure everything is in place or not, right? So first validate everything is in place, then only run the expired snapshots, right? Because it does the hard deletion, right? So this is like, again, the order I have defined, and this is how my impression is should be done, right? Okay. So yeah, because I'm part of Dremio does this stuff slightly differently. And a lot of innovations are happening. Even the Cloudera talked about it, right? The coming up with the auto optimization and smart optimization. So all the engines, all the ecosystem in the Iceberg side, they are spending a lot of time on as like users should not come and understand when I should run the maintenance, right? The engine should have that capability to self-understand and automatically does all those things. Once you have defined, I don't want time travel, it will keep doing those things for you. Right. This is like one of the guy who has a lot of Iceberg materials. If you want, everything is on somewhere on the Google, you can scan this code. Yeah, sorry. Okay, yeah. I think I don't have enough time for Q&A, sorry. I took
Yeah,
more
thank you,
time.
Naveen. Yeah, we are ahead of time already.
Yeah, sorry.
Hey, hello, everybody. Thank you so much for kind of deciding to spend your Saturday afternoon with us. I hope we live up to the hype. So again, thank you to Samriddhi and Cloudera for hosting this, and great presentations from Akshat, Naveen. Thank you so much. So I think they kind of focused on the technology part of it, right? But my focus is a little bit more on why should you even care, right? Why are we spending this Saturday even trying to understand, right, what this thing about Iceberg is, and how can it essentially help us get a better salary at the end of the day, right? A kind of get a better job. So with that thought process, so I'm currently working in a Big Four. I have roughly 14 years of experience. So today I lead globally a platform pre-sales team. Okay. So the job of my job and my team's job, so to speak, is to understand what are those technologies that make sense, right? That we need to invest in as a company, and how can we integrate it into our ways of working or our central platform sort of an approach. Once I go through it, you will understand it. Again, this is just a slide that my lawyers asked me to put in. So this is all me. So this is nothing to do with my company. Okay, perfect. So again, very quickly, this will be just like a very simple thing. Some context setting. I will explain to you why we are here today, right? And why we think we should think of learning what is Iceberg and what all of this cool stuff is. Then we will focus a little bit on how we can ensure that Iceberg kind of fits into our overall data strategy of an enterprise, and some closing thoughts. Okay, so if you see this thing, this is a very nice chart that shows how much money are investors putting into GenAI, okay, startups. So if you see in the last 3 quarters of 2024, they have spent more money than 2022 and 2023. So the money just keeps pouring into these GenAI-based ecosystems. What are the top 5 companies? We know OpenAI, right? They had done that $6 billion investment. XAI, Elon Musk, he is always on the news. Safe Superintelligence, this is a startup that Ilya started. So if you see, these people closely are getting billions of dollars of money. Now, why? Are these investors crazy that they're pouring in billions of dollars of money into this thing called GenAI? So this was a nice analysis that was done. And if you see, they compared the 200 startups who are working today on GenAI with 200 startups which were working in 2018 on SaaS, which we call the golden age of SaaS, right? That 2018-19-ish time. And you see, they're saying GenAI startups are making an annual ARR, it's called, $30 million ARR, 3 times faster than SaaS. So this means these GenAI startups are actually making money, right? It's not like it's just a fad. They are actually making money 3 times faster than the SaaS ones were making. If you just take a look at OpenAI, right? GenAI's poster child. 2023, OpenAI's revenue was $1.6 billion revenue. In 2024, they have reported roughly, again, they are not a publicly traded company, so they don't report formally, but Wall Street Journal is reporting roughly $3.7 billion of revenue. So they have doubled from 1.6 to $3.7 billion in 1 year. Crazy money, right? This is like billions we are talking about, not even millions. So OpenAI had done a VC round and raised $6.6 billion at a valuation of 157. Now there are reports that they will get another $40 billion, making their valuation $340 billion, which is 1/3 of $1 trillion. So just imagine the numbers that are going around, right? I mean, it's like crazy numbers. So the question is, the startups are getting money, the investors are pouring in the money, but are enterprises getting the benefit out of GenAI? Because again, Cloudera is an enterprise, my company is an enterprise, maybe some of you are representing enterprises, right? So are enterprises making money basically at the end of the day, right? Everything stops at money. So if you see, this is a report that one of the big fours did, CEO survey. Out of 100 CEOs, 34 are saying they have done something good out of GenAI. That means roughly 66 are saying, no, man, I am not getting any benefit out of GenAI. The benefit I was expecting out of GenAI, I'm not getting. So out of 100 CEOs, 66 CEOs are saying, GenAI is not making me more money. Okay. Similarly, if you see, out of 100 CEOs, 66 CEOs, so 33% are saying, I can enable GenAI in my ecosystem. That means 66 are saying, no, I cannot. So you can see, right, there is a gap. So at one point of time, these investors are kind of putting in millions of billions of dollars, and OpenAI and this consumer B2B startups are making like crazy sort of money, but enterprises are not getting a lot of money. Why? So this is a dilemma that every business leader is facing right now. Like, how can I get GenAI into my ecosystem? Maybe even in your enterprises, maybe the same thing is happening, right? I mean, you go to your boss and he will not even approve your budget if you are not doing anything related to GenAI. That is how the situation today, to be very fair, right? So again, very quickly, section 1, what we did, right? We understand that there is a lot of money into this GenAI ecosystem, but at the same time, our CEOs for enterprise companies are saying, guys, something like this, right? This is a very nice cartoon that the CEO is asking somebody, man, how do we make money out of GenAI? And that person is asking ChatGPT. The same thing, right? Kind of like that. Okay. So again, so this was just overall, right? Now let's come to the data part. Okay. So we all know that data is very important. Everybody understands that. And with AI, it's even more important, right? Without good data, you don't have good AI. That is what this is showing, right? That, and as 2022 or 2023 survey said, up to 73% of the data in an enterprise is getting unused. So if you have 100 terabytes of data, 73 terabytes you are not even using for your analytics. So just imagine kind of the loss we have, right? And you compound, and all of this will get compounded with AI, right? I mean, AI will need this data, and if you don't have a nice way to talk between yourselves on the data part, you will all get into some sort of a problem. So this is something that will show the current structure. So this was an analysis that was done by Redgate. This is just showing how many companies today have more than 2 database platforms, just more than 2. So as you can see in 2024, we have 74% of the companies who were surveyed as saying, in my company, I have more than 2 database platforms. Now let's see what is happening here. More than 5. See, 29%. Okay. So you can, and again, I'm going a little fast because otherwise I will not be able to finish this. So you can see again, so any company you pick, right? You pick a stone and put it on a company, you will see that company is using Neo4j for Graph, Cosmos DB, a little bit of Glue. I mean, it's like all over the place. Maybe Cloudera data platform, Dremio, all of those things, right? It's like a best of breed. So why are they saying that I need a best of breed? Because obviously they are saying that I need the flexibility, I need the best of everything, cost savings, I have different sorts of needs. So that's why in every single enterprise today, you will see there is not a single tool. So those days are gone. When I started my career, we had an Oracle warehouse. Our reporting solution was also on Oracle. Our ETL was also on Oracle. We were all trained on Oracle, and we just did Oracle for the first 2 years of our life. Now you go to any enterprise, you will have a little bit of Oracle maybe, but you will have all of this Starburst, Dremio, you will have a little bit of Cloudera, AWS, everything is there, right? So what is the biggest challenge that people are saying about this enterprise? And you see the second challenge, data integration complexity. So the moment you have all of these different sorts of data, right? A little bit of data in AWS, some data is in this S3 bucket, some data is in a blob storage, some data is in my on-prem, some data is in a proprietary database in Oracle. This integration becomes a very complicated situation. And if you cannot solve this integration problem, you will not be able to make money out of GenAI. That is why, if you see now, we will connect it back to why the CEOs are saying, man, GenAI is all good, right? This ChatGPT thing is nice, but I'm not making money out of this because they don't have access to that data, right? That can help them basically do something. If you see, this is one report. I think the slides will be shared. You can check. This is actually a survey done by Dremio only. And this is another survey that was done, same sort of things. If here also, if you'll see that they are saying efficient enterprise-wide integration of data, that is the second most problematic issue after data quality. So data quality, we should not even discuss. It's like even bigger stuff. But the wide integration is a problem, right? So again, section 2, what we did in section 1, we identified that GenAI has a lot of money, but enterprises are not making money out of it. In section 2, we focused on the fact that there is a problem in our data state today, right? So, and maybe we can relate it, right? That there's a multitude of data sources, which is making this entire data ecosystem very, very complex. Good for us. We will make more money as data engineers and data architects. But for enterprises, right? If you want to figure this out, you have to figure out how you can very easily access all of the different sorts of data across the different platforms in a holistic way, so that you can then use that data for AI, and then you can use that AI to make money, basically. Okay, so with this, I think we have established to some extent that in this modern enterprise ecosystem, there is a problem with the data integration, right? There is a lot of data in the system and we are not very well integrated. The data cannot talk to each other normally in a very easy way. So one of the surveys that was done, and what they're saying is should be the role of the chief data officer of a company. One of the roles, if you see, fostering innovation through data collaboration. So we need to identify what are the technologies and tooling that we can standardize across an enterprise, which can help in data collaboration. So that if today I am bringing in some data from my client, I bring it in a format that tomorrow if another vendor is coming and trying to read that data, they can also understand that format. So now you can kind of see I'm making the case for having something like Apache Iceberg, right? So this was kind of the context, right? Why should we even think about this, right? It's not like I Google Iceberg. See, if you Google Iceberg, you will find tons of tutorials on how to do this, all of this, which is very nice. And we should do that. But why is it even important in this enterprise context? Why is it suddenly so popular? Why did Databricks buy Tabular? Huge billion-dollar valuation, right? Because of all of this. This is the challenge that every single enterprise in the world and their CEOs and CDOs and CTOs are trying to solve. It's not like Iceberg will magically solve everything, but it's a good step in that direction. So if you see one of the surveys that was done, again by Dremio, they're saying that, I think there was a question, right? Like Hoodie versus Delta Lake versus Dremio. I think that war has kind of been settled. I think most of the people are going for Dremio, even though right now there is a lot of Delta Lake. So if you see here, this analysis is saying, these are companies who have not done any lakehouse. So lakehouse is nothing but data warehouse plus data lake is equal to lakehouse, this concept. So they're saying, if you see, out of the people that have not adopted any sort of a table format, 30% are inclined to use Iceberg, 23% Delta Lake, 13% hoodie. So you can kind of see the trend, right? That the world is saying that, man, Iceberg is what we want to use. Doesn't mean all of these things, it's a huge space, everybody will stay. But this, I think, is the clear winner. And that's, I said, right, again, maybe Iceberg has won, maybe. So again, with all of this, what I'm trying to kind of come to is that there is a data integration problem, guys, right? That's what we are trying to say. And your open table format that everybody can understand. Everybody in your enterprise can understand this open table format of Iceberg. That helps. So now I am making the case that you need to make the Iceberg thing a part of your platform strategy for your data estate. It cannot be an ad hoc approach. Okay, one data engineer likes Iceberg, he is using Iceberg. Somebody else likes something else, he's using something else. No, what I'm saying is that because of all of these problems that an enterprise has, the only way to solve that problem is, one of the ways to solve that problem is ensuring everybody has access to the data in a very easy standard way so that everybody can understand everybody else's data. And that's why I'm saying that Iceberg, right? Because it is kind of has won the battle, right? So to speak, if a company standardizes on Iceberg as the standard table format that every single data set in that company will use. So this is something that has to come from the top, guys, right? That's why I'm saying, right? This is my business. This is what I do in my company. I do all of this analysis, and then I try to determine what should my company invest in and what should I kind of put into the overall strategy. How are we doing on time? Samriddhi, how are we doing on time? I cannot see that. 10 minutes. Okay, perfect. Okay. So what does it mean, right? When I say that let's make Iceberg the standard across your data platform, right? It's a very vague statement. So what I mean that, as I said, right, we have to make that table format as the standard format in that enterprise. No questions asked. If you want central funding, you have to use Iceberg. And if you go on your own way, we'll not give you money as a company, basically. That is the way. All data engineers should be trained with all of those things that Naveen was saying, right? How to handle Iceberg, what does metadata mean, how to compact, right? It cannot be they're getting trained on all of the other things. They need to focus on that. We should only allow query engines and data platforms, like let's say Cloudera data platform, for example, an enterprise, because who are providing first-class support for Iceberg, right? Because we are doubling down on Iceberg. We want to make sure as an enterprise, if we are investing in Iceberg, the partners and the vendors we are working with, they also treat Iceberg as the #1 first-class data support. And as I said, we obviously need a centralized catalog. This is where sometimes things break down in a big company, right? I'm talking about companies with $40 billion revenue, like my company, right? So here, there is so much data in the system, right? So now how do you ensure that I can see what you have, you can see what I have? So that is where this centralized catalog, whether you use this catalog, which is based on this concept of this thing that Apache REST, they have now enabled this REST API catalog. There are some other catalogs as well, whatever it is. And that should be a self-service option. This is very important, guys. See, your data engineers and your data architects, they will always go the path of least resistance. So if you really want your teams in your companies to use Iceberg, you need to make it easy for them. Simple. You have to train them, as I said. It has to come from the top, from a funding perspective, and it has to be self-service. When I say self-service, accessing the catalog, ensuring that your data set will be registered to the catalog, all of that needs to be self-service. It should not be that you raise a ticket after 7 days, a data admin who is the catalog admin adds you, then it will not work. So these are all of the things I'm saying, guys. This is when you are shifting your thought process from being an individual person who is writing Iceberg queries to stuff as data leaders or as leaders of your organization you need to think of when you are trying to scale it at a huge level, right? This is like terabytes of data, thousands of data engineers. The best thing is, this is what we do, right? Every single company in the world who handles data, what are they doing? They're getting data from somewhere, they're processing the data, then they're putting it into some sort of a common data model and then reporting on that data. Essentially, that's what, this is a standard medallion architecture, right? Bronze, silver, gold. The best thing is, we have Iceberg at the below, right? Every data set here can be on Iceberg. Again, it's a table format, right? It's not the data format anyways. Your data is anyways in Parquet or wherever, ORC. You're just using the Iceberg as the table format. Everybody in your company is using this. You have this central catalog. Again, as I said, self-service. then what is stopping people from using Iceberg? Nothing, right? Every single data processing engine in the system will support that, right? So as you can see, this query engine can be Dremio. This can be the Cloudera data platform that was being talked about, right? Anything can be done. And the good thing, again, the good thing is today, if you have here in Iceberg, let's say today you are querying using Dremio, tomorrow you don't like Dremio, or your company starts auditing Dremio, and you have to move out of Dremio, then you can just put it to Starburst, point it to the same catalog, it will work same. Similarly, it will work. This is the power of an open table format, where you are not kind of married, like we used to be in when I was in PwC, when I started my career, right? We used to be married to Oracle, we used to say, right? I mean, even if tomorrow Oracle would, let's say, shut down, PwC will go out of business. Simple, that day only, right? Not even a day further. But those days are gone, right? People are not in that business. So the moment you have an open table format, and this catalog, as I said, right, you can use any catalog as long as that catalog respects that Iceberg REST API specification. And then perfect, you can do whatever you want, good. So 3 main reasons why we are saying that we are bullish on Iceberg, right? One thing, as I said, right, we are decoupling the processing engine and the file format. That's what I just mentioned. As long as the data is in this Iceberg table format, I don't care what you use. You can use, as I said, Dremio, Databricks, everything, whatever you want, you use. Because with this open table format, I'm not married anymore to my table format. Very nice, well-run open source project, right? So you have a nice thing going on with Iceberg, very good community, lot of PRs coming into the community, a lot of business. And now, as you can see, all of the big enterprises are kind of going all in. But at the same time, this is a pure open source project. So tomorrow, Amazon and Jeff Bezos cannot come and buy this, right? And then screw every other enterprise who was kind of, right? Because this is stuff that an enterprise needs to think of, right? You cannot just choose you have to think of all of these things, right? Okay, what if I am today, HashiCorp, for example, right? They were open source, people were using Terraform. Now they have been bought by IBM. Now let's say you are a company who is auditing IBM. How will you use it? Very complicated situation. So this is a good open source project. I don't think they will ever be bought by anybody. And compatibility with most of the cloud data workloads. AWS has first-class support. I said, right, we need vendors who will provide first-class support, because you will not be able to create your own query engine, right? You will rely on the AWS, you will rely on Google, you will rely on, so if Google supports a query engine that supports Iceberg, then your thing is kind of solved. And this is very quickly, so this is what I say when I mean that it has to be a platform-centric approach. So this is the central platform team. The central platform team is managing all of this, Starburst, Dremio, Cloudera, and these are individual application teams who can access this in a self-service mode. So all of the admin, everything we are doing here as the platform team, and all of these product teams, these are individual teams, they're accessing the data, okay? And anyways, so this was the section 3. What was the section 3? We can kind of conclude to some extent that Iceberg has won the battle, right? So Iceberg is, let's say, more cool, more popular than Delta Lake and Hoodie. But at the same time, to really make money and to really be able to use this at the scale we want to, it has to be embedded in the overall strategy of your enterprise, right? So it has to be something that your enterprise doubles down on from a training perspective, from a first-class support perspective, from a vendor partnership perspective. You need to be all in on this thing called Iceberg. And as I said, it has to be self-service. That is the only way your data engineers and data architects will use this. So some closing thoughts, right? As I said, right, this AI-ready data concept is coming a lot, right? That I need, and this is a very nice thing, right? Leadership will come up with a new AI initiative. Say, guys, we need this latest chatbot, and you try to find the data, and there is no data, nobody knows what is happening, right? So that's something, right? Having a strong data foundation with good governance, unified cataloging, this is fundamental. And this is where I really think that Iceberg can play a role to a large extent. And lastly, I will just leave you with, I don't know how close you are with this thought processes. Again, I am today in the Cloudera office. Cloudera was the epitome of the big data companies like Cloudera, Hortonworks, all. But now there is this concept of small data. I don't know whether you guys are aware of this. There is even something called a small data movement. Okay. So what people are saying now is that, do we really need these big processing engines with a lot of processing power, right? These things cost a lot of money. Spark costs a lot of money, right? These are not free stuff. So here, if you see, they're saying what is big data? They're saying any data set which is more than 10 terabyte is big data. And they're saying 95% of databases don't have big data in the world. And 99.9% of queries don't actually run on big data. So what is happening, at least in the company I also represent, we are now seeing a lot of small data sort of use cases. Use cases that you will stay on your laptop. It will never even go to a cloud sort of a thing, right? That is also where let me just show you very quickly. So the same thing, if you see, same thing Iceberg all, and you see this new thing called DuckDB. So DuckDB is an in-processing, you can call it a OLAP engine also, right? To some extent, sorry. In memory, exactly. So it will run on your laptop, basically, right? So there are many things today that we do that really don't need a big data processing cluster, right? So again, as long as you have the data in that same Iceberg format, right? And if the data is small, you just use your laptop and DuckDB. And if your data is huge, you use Cloudera data platform. So I just wanted to kind of finish with this. So thank you guys. And I'm on LinkedIn and stuff. So in future, if you want to reach out, and I will be here also. So thank you so much.
So good afternoon, everyone. And I hope so. So much buzz around the Apache Iceberg is going on, and you guys have already passed through 3 sessions on Iceberg, so you know very well about the Iceberg. I'll be talking to a very specific topic, which deals with not only data, but data security. Because Iceberg, as you saw in previous presentation, it will deal with a lot of data, and it will also deal with a lot of query engines, which will access that data. But where does the data security comes in, right? Because so far you must have seen that there is no talk about the security within the Iceberg, for data security within the Iceberg. So the topic for my presentation is data-centric security with Apache Iceberg. I'm Vishal Paranjpe. I'm Director of Engineering in Protegrity. And I'll take you through what we are doing, how we can leverage the data security within Iceberg using Protegrity, as well as what future projects which are being taken under for data security with Iceberg. So I'll quickly introduce you about the Protegrity. We are a passionate group of cybersecurity experts, and we deal with a lot of data, especially to secure it. And we can claim that more than billions of individuals' data we have protected worldwide. And we have around 120 patents and patents pending, as well as we deal with our partners to work on data security projects as well. So Cloudera is one of the partner we have. Now, first, let's look at what is data-centric security. And I would like to keep it interactive session. So if you guys already know about data security, you can also tell. Have you guys heard this term as data-centric security so far? No? Okay. So data-centric security is embedding the protection of data as near to data as possible. And mostly the focus of organization is on securing the systems, networks, or applications, right? But we all know that somebody can always break the systems, hack the network, hack the applications, and reach to the most precious, what we call data, right? So that's the most precious entity. And what we deal with is protecting that entity. So even if systems are broken, networks are or applications are broken, if the person reaches to the data will remain in the secured form, and it will be of no use for that person because it will be either tokenized or encrypted. So and we also make sure that the utility of data is preserved. So we make sure that protected data, wherever it lies, it is usable in any form. Now, how can we leverage the data security with data security within Iceberg using Protegrity? So if you see, there are two ways with which we can we can have integration of Iceberg with the data. One is we can register our data. By registering, we mean we can read the protected data. We just need to give the path of the data where the data lies, and Iceberg will read that data. Now, here, this sign which you're seeing, it's a protected data sign. I mean, this is the Protectability logo. So I'm just mentioning it as a protected data, which is there lying in the data lake. Now, there are a lot of query engines which can access this data. So how they will access is they will go through the Iceberg, read the protected data. Then they will have to apply the unprotection methods which are available. And then after that, the data will be ready for analysis or further processing. So this is the way the protection will work end to end if we are registering the data. The second way is we can write the data. So by writing, the protected data which we have in data lake, we can write it into Iceberg tables. Again, the post-processing will remain same, where the query engines will read the data for processing, but before that, they will have to unprotect that data, and then they can analyze or do further processing on that data. I will give you an example of it. I wish I would have been able to give it a live demo, but I have brought some screen grabs for it. So this here you are seeing is a Hive table where first name and the last name are the protected columns. These are being protected with Protectability UDFs. And now how we will shift this data into Iceberg is by creating the similar Iceberg table and then inserting this data into the Iceberg table. And once the data gets inserted into the Iceberg table, you will see the same protection or same protected fields in the Iceberg table as well. So you won't be able to guess what the first name and last name is even in Iceberg tables because it has been moved as a protected data only. Now, how we can read and unprotect this data, right? So we provide the Spark UDFs, which are being used here. This is the query what you're seeing here. So this is the UDF, which is being used to unprotect the data. And then you can see the unprotected data available from the Iceberg tables. Using Spark, we have queried it. So this is how the data can be accessed from Iceberg, and even if it is in the protected form. But do you guys see any challenge with this method? Let's say if we are moving the protected data in Iceberg. So do you see any challenge? What's there? Yeah. So there is another layer what we are introducing here, right? Otherwise, we can directly query from Spark to this data lake and get the data. But here we are trying to utilize Iceberg's efficiency, Iceberg's capabilities, because it will be much faster. But with this method, it may be possible that that capability cannot be utilized fully. Second, the Iceberg will remain completely agnostic of the fields which are stored in its tables, right? If those are protected or tokenized or encrypted data, then Iceberg don't know what that data is. And we'll have to always grab full data first, then apply the filters on it, and then do the further analysis and processing. So what if this capability comes into the Iceberg itself? Because Iceberg is something, Iceberg is we can say the software which is getting so much popularity across now. And there is a need that if it is being used so much across, then we must add this security to its layers as well, so that data remains secure end to end. And if we do this, the security layer addition within the Iceberg, then a whole data pipeline, which from ingestion till the processing or querying, data will remain secure end to end, and only authorized user will be able to see what data is. I mean, what authority they have to see the data. So to just going back to previous slide. So how we will be leveraging this, or how we are working on this, is by using the Parquet Modular Encryption. I hope so. Few people must be aware about the Parquet Modular Encryption. If you're not, I'll cover that in the next slide. But we will be leveraging Parquet Modular Encryption within Iceberg to introduce the security within Iceberg layers. Now, what is Parquet Modular Encryption? So if you see, Parquet Modular Encryption encrypts the data. It uses the KMS, key management system, for storing the keys and making sure that the data is secured. It has its own benefits. So first of all, for this use case, let's consider we are thinking about the data which is getting stored in Parquet. And that's where we are researching right now. So Parquet Modular Encryption, I mean, it has quite a good properties. One of them is selective encryption, which makes sure that the specific columns and the metadata gets encrypted. It also supports the full and partial protection of file and metadata. It supports the local encryption. So wherever the application is running, data will get protected over there itself if we are using the Parquet Modular Encryption. And the storage server won't be able to see any plain text. So always data will go in protected form. It has authenticated encryption, which makes sure that data integrity remains the same. It uses the relevant algorithms to make sure that data integrity remains intact. Also, it minimizes the file read and write operations and the throughput. So it's a minimal overhead what it introduces within the process. So Parquet Modular Encryption, this could be the use case which we can work on, or we are working on, which is using the Parquet Modular Encryption in Iceberg using the Arrow libraries. So Arrow libraries use Parquet Modular Encryption within, and the capabilities of PME, we can call it PME, are being utilized by Arrow libraries. So what happens, or what will happen in this case, is the Arrow libraries will take care of data read and write within Iceberg, and Iceberg will only be keeping the metadata information. But this particular protection will happen within Iceberg. So this research is going on right now. What we are also introducing is the external data protection service support within Parquet Modular Encryption. Right now, Parquet Modular Encryption does not have any support for calling or connecting to the external protection services, data protection services. So this is the work which we have taken under, and we are working with community to introduce this within Parquet Modular Encryption. And this will help enable this particular encryption or this particular data security area to boost in terms of quality, because if we use the external data protection services, they bring their own advantages and the robust security along with that. So that way it will help us introduce this external data services protection service within the Parquet Modular Encryption. Once this Parquet Modular Encryption is enhanced to handle this, the next step will be to introduce or increase the capability of Iceberg to make sure that it has the capability to integrate well with PME, because right now we need to make sure that this has been included through Arrow libraries within Iceberg. But that is something which will be changed in future. On the same path we are working as well, where Iceberg will have the capability even to integrate with the Parquet Modular Encryption. With this, the presentation comes to an end. If you have any question, you can ask. Yeah. No, sorry, I can't hear. Yeah.
I was just asking whether the Parquet Modular Encryption that you talked about, does it support other file formats like Avro?
No, right now the focus is on Parquet only.
Okay.
Iceberg supports Avro and OCR formats, but we are focusing right now on the Parquet because we are utilizing the Parquet Modular Encryption.
And just another question on the tokenization part. So how do you control what fields need to be tokenized? There has to be somewhere where you get this information, right? And down the line, if I want to de-tokenize the data, how is that controlled?
Yeah, so we are specialized in this area only, protection, which involves encryption, tokenization, and masking. So tokenization has its, we can have a full session around it. So you can write down to us. You can also visit the protegrity.com because all the details are mentioned over there. And we'll get back to you once we have some questions around that.
Thank you.
Yeah.
So just one question, Vishal. Thank you. Thank
Yeah.
you for the session. So where is this running? I mean, is this a SaaS service? I mean, how do you link it up? Is it like you are running this, I have to install Protegrity on a VM? I mean, how does this thing work?
It's on AWS. We have cloud native support. So we also have all the services installed on AWS.
So basically there will be an API call or something to you to get this. I mean, how will the networking work? I mean, so the data is in, let's say, my S3 or something. So then how is this happening? I mean, is there some sort of API call that happens in the backend or?
Yeah, so how we have set it up is the Protegrity solution is also installed within our network itself, right? It's an enterprise tool. So right now we do not have any SaaS available. So you need to connect to your enterprise and then get the data protected and unprotected over the network.
Okay, understood. Perfect.
So from a security perspective, right, like Iceberg does solve a problem in general of avoiding vendor lock-in. But with this approach, I see a little bit of that. So how are we planning to eliminate that, right? So for example, if customer states in multiple data, so as you said, you are available on AWS, but what if Iceberg data is on Snowflakes? So how does the security applies to that data as well when they're transmitted?
So Protegrity protection, you're saying is only on AWS?
So I'm basically saying how do we so security in general, right? If your platform is on AWS, but the data, for example, Iceberg in general is to build to avoid vendor lock-in, right? To have access to this data overall.
Yeah.
So how does this work when we talk to other data state in Iceberg?
So we are also not vendor locked. We have support on all the clouds. And our enterprise solution can be installed, as well as the most of the popular query engines, what we have right now, right? Athena, Snowflake, Spark, we have protectors available. So those can be integrated within those query engines, and protection and unprotection can be performed.
Of course. Basically, it's an integration with the engine level, right?
Yes, yes.
Yeah. Hello. Yeah. The question is, whenever we are using this service, right, is it a process that is running and then connecting over network to like do some encryption and decryption, or is it like working like within a VM itself without any network IO?
So this is, as I said, it's an enterprise solution where there is an enterprise security administration centralized tool, which is responsible for policy management and all the security policy management, as well as the logging and all the the connection to the servers wherever our protectors are installed, right? So definitely the traffic will go over the network, but this protection method, if you are asking specifically how it will work, so our agents get installed or our code gets installed on the services where this protection will happen as well. So we have protectors, as I answered to him. Let's take an example of Spark Protector, right? So we have a big data protector which gets integrated within your big data solution on Cloudera. If we take the platform, it gets installed over there, and based on the policy what is being created, it interjects with the whatever the query is. You need to use our UDFs which are there, and then those will perform the protection and unprotection operation. So you need to specifically right now specify the UDF. If you're taking an example of big data protector or databases protector, it gets integrated and installed on those systems. You need to use that specific UDF if you want to protect. If you need to use unprotect UDF if you want to unprotect, and then it gives the query result in the form you are expecting.
Got it.
Yeah, but the protection enforcement point, it is a separate service which also get installed on the same machine. And then they all interact with the enterprise security administrator to bring the policy or policy changes if those are being planned by the CISOs or whoever is whoever is the administrator of that security tool.
Got it.
So you can still note down, it's Iceberg Meetup Bangalore @protegrity.com. If you have more questions online, also we have few people. If you have question, please reach out to us and we'll be happy to answer.
Vishal, we have a question over Zoom. How is it different from Apache Ranger?
Okay. Apache Ranger, I don't have much insight into Apache Ranger, but our is full-fledged enterprise security solution. And this has been, you can definitely ask this question. I don't have much insight into Ranger, so I cannot compare and answer right now. Yeah. Actually, I'm unable to hear you completely. Yeah. So we also have access control. Ranger has limited capability, we can say, and ours is having a lot more capabilities than Ranger. But I don't have much insight, so I cannot compare one to one.
No problem. Thank you so much, Vishal, for the insightful session. Thank you, everybody, for attending us.
Thank you so much.